Figure 2 shows a sketch of a curve C with this equation, and we're asked to find the derivative. So there's three things multiplied together. The first thing I did was actually multiply that bracket out. You can just kind of ignore the 4 and bring it back in at the end, but I decided to times it to give 4x squared minus 8e to the minus 2x. And now we can use the product rule. So this can be u, this can be v, f, let me do it over here, f dash x is going to be u dash v plus uv dash, the u and v differentiated. So u dash is going to equal 8x, v dash is going to equal, using the chain rule, bringing that minus 2 down, minus 2e to the minus 2x. So that means f dash x will be 8x e to the minus 2x plus 4x squared minus 8 times v dash, which is minus 2e to the minus 2x. We just need to factorize that e to the minus 2x out. So what I decided to do was just get all the terms like separately. So I'll get minus 8x squared e to the minus 2x, and then plus 16 e to the minus 2x. And now I can factorize it out, although we're going to put it at the very end. Also factorize an 8 out, leaving me x minus x squared plus 2, which I can just write as 2 plus x minus x squared. Okay, I think it's fine to go straight from here to the answer. In the second part, we're then asked to find in the simplest form the exact coordinates of the stationary points. So that's going to be here and here, where f dash x is 0. So it's going to be when 8, 2 plus x minus x squared e to the minus 2x is 0. We can divide through by 8, and we can divide through by the exponential because it's never 0 itself. So then they're not going to be what causes the function to be 0. It's going to be this quadratic that causes it to be 0. So that means that x squared minus x minus 2 is going to equal 0. I can factorize it. X minus 2, x plus 1 equals 0. So we get two situations. X is equal to minus 1, or x is equal to 2. Let's put them back in to the original function to get the value of y, because we're asked for the exact coordinates, not just the x values. So if I put in minus 1, I'm going to do 4 times 1 minus 2, that's minus 4, e to the 2. You can use your calculator as well, of course, to help. So 4e squared. Sorry, it should have been a minus. I think I did say minus, then I forgot to write it. Because it's 4 times minus 1 times e to the e squared. That's going to correspond with this minimum down here. It's negative. That's how I kind of spotted I'd missed the negative, to be honest. Then when x is 2, I'm going to do 4 times 2, because this bit here is just 2. So 8 e to the minus 4. So that's that one there. So final coordinates, I'm going to write minus 1 minus 4e squared and 2, 8e to the minus 4. We're then asked in part C to find the range of two related functions. G of x is 2 times f of x. So I'm going to start with the range of f of x, actually. I think that will give some insight. And f of x, remember, the range is all the possible y values. So it's going to be all the values including or above the minimum. Therefore, f of x must be greater or equal to minus 4e squared. And when I times by 2, I stretch the function by scale factor 2 in the y direction. Actually, that minimum is going to become minus 8e squared. It's going to end up sort of down here, but the same shape is going to be going on. It's going to sort of look, it's still going to go through 0 at the same place, going to come up, but it's still going to go to infinity, and it's then, but the minimum now is going to be minus 8e squared. So that's actually going to be my answer. G of x is just greater or equal to minus 8e squared. Now, h looks really similar, we just minus 3 from it, but there's an extra little catch, because in the first part we had all real numbers, but now x has to be greater or equal to 0. So I'm going to look at f of x, I think, when x is greater or equal to 0. So basically get rid of this bit here. And suddenly things have changed because now it doesn't go to infinity and it doesn't hit that minimum. The minimum point is going to be when it goes through the y-axis, so when x is 0. So x is 0 implies f of x will equal 4 times minus 2, that's minus 8, e to the 0, so it's just minus 8. And then now it's the maximum is going to be what we had before, 2, 8e to the minus 4. So that means for x greater or equal to 0, that I know I haven't dealt with h yet, I'm just doing one thing at a time, but f of x is going to be greater or equal to minus 8 and less than or equal to 8e to the minus 4. So if I then apply these transformations, I'm going to first of all times by 2. In fact, that's going to be my g of x. So I can just, this is, remember, when x is for this domain, but it's going to be that g of x is now between minus 16 and 16e to the minus 4. I've just multiplied both by 2. All I've got to do now is minus 3 from them. So I've done a stretch of my function, and now I'm going to do a translation in the y direction. I just minus 3 from all of my values. So finally, I'll get minus 19 is less than or equal to h of x, this function that's just defined for x greater or equal to 0, and that is going to be less than or equal to 16e to the minus 4 minus 3. This one is quite tricky, I think. Easy to slip up on it. So that's my suggestion anyway. Deal with f of x for x greater or equal to 0 to get a picture of what's going on. Like you can take the graph and just cross out the stuff to the left of the the y-axis. Work out the minimum here and the maximum. Okay, we already know the maximum, the local maximum, and then work out the intercept is the minimum. Okay, figure that out. It was minus 8, and then just scale it up using the transformations from there. Okay, well done.